today will be, as Tim mentioned, we'll go into the depths of, what exactly is StarTree serverless, beginning with why we decided to build serverless in the first place, talk through some of the features of serverless that are unique to this offering. And we'll actually attempt a live demo today for you folks. And then the second half, Neha will go into the architectural details of how we built it, how we are scaling it for all such users. And so before just getting into that, just wanted to quickly introduce StarTree Cloud for those who haven't tried it so far. StarTree Cloud is our real-time analytics platform for building analytical applications and solutions. It is a fully managed offering from StarTree. It's cloud native and enterprise ready. So we have lots of big customers are driving mission critical workloads today on StarTree Cloud. So up until StarTree serverless came along, these were the two deployment models we had before. First one is BYOC, or bring your own cluster. This is where we deploy StarTree Cloud in the customer's account, in their VPC. And then the dedicated SaaS offering. So it's an environment that we host in StarTree account, and customers just connect to it like any other SaaS product. So both of these work fine for a production scenario, but getting started with these two offerings is quite difficult. Or there's some friction involved, right? There is infrastructure that needs to be provisioned for both of these, and we need to deploy software, and a fair amount of capacity planning needs to happen before we get started. So to reduce this friction for developers, we are very excited to announce StarTree Serverless. This is essentially an always-on SaaS service that you can simply sign up and start using. So no need to provision any infrastructure or deploy software. You just connect and start building your applications. And serverless is the technology that's powering our new trial experience. So earlier we used to have a 30-day free trial. Now we are making it a free forever trials. So serverless is essentially targeted for developers, especially new users of Pinot who want to quickly get started without even downloading a Docker image. They can connect and start testing it out and start building applications. It's also horizontally scalable. So you have once you have tested something, you have the option of moving to a more production-ready setting if you choose to. And finally, it's also high performance. Right? So if you think about it, the performance of serverless is better than the smallest cluster that we can provision for a trial. And we'll speak more about that in some time. So let me discuss the different features that we are also announcing as part of the serverless. Right? So this was the old model of how we did StarTree Cloud trials almost a year ago. Any new users registering on StarTree Cloud, that triggered a workflow where we provisioned a dedicated environment for that set of users. And this again went through infrastructure provisioning, software deployment, and so on. And took about 15 plus minutes. So you're just signing up and waiting for something to happen. And also involved a fair amount of work on our side to power this. And if you look at the sort of the data model behind this, right? So new users would be mapped to a unique StarTree environment. And we ran many of these in our cloud account. So this was the old model. With serverless, now we are transitioning to this model, where if a new user signs up, you just get assigned to an existing StarTree environment. And to be more precise, the new user is now getting assigned to a new abstraction that we are also announcing as part of this, which is a StarTree workspace. And we'll talk about that in the second half. But now we have many of these workspaces running within the same StarTree environment. And this allows us to do the instant provisioning. So anyone coming in is assigned the StarTree workspace within seconds. And you'll see this in the live demo. when you do get your hands on a workspace, these are the things you expect from that experience, from the StarTree workspace. So the first one is our data manager. This is the low-code, no-code experience for ingesting data into your StarTree cloud. For those who have used it, we are also rolling out a bunch of new enhancements to this, including new connectors, new data sources support, along with lots of improvements in the data modeling experience. So data manager will let you preview the auto-infer the schema from your source data set, preview the transformations that you want to test out before anything is created in Pinot. The other big improvement we have added to this is the time column inference. So that again reduces the friction for new users of Pinot. And then finally, when you create something through DM, we are also automatically tuning some things like indexing recommendations that gets automatically applied to your table config in Data Manager. The other thing we are rolling out as part of serverless is a brand new query console. So you no longer need to go to your open source Pinot UI, which is a little bit clunky right now. And in this, we have reimagined the user experience in the new StarTree query console. So it gives you all the functionalities of the old query console, but we also added some enhancements like syntax highlighting, the semantic validation, and so on. And we'll keep investing in this. So pretty soon, you'll have autocomplete in the new query console as well. That's coming up soon. And then we're also announcing two new features in private preview. Hopefully, you've seen a demo of that in our booth. If not, I highly recommend that. The first one is the performance manager. So as you test out queries in the new query console, you can now have this sort of co-pilot to tell you how to tune your queries automatically. So if you can see on the right-hand side, it analyzed the given query, looked at the execution stats, and it can tell you what you can do to make this query run faster, which can include things like adding materializing a derived column for assisting the query or creating of new indexes like StarTree index. So we actually have a live demo of this in the booth if you want to check it out. And the second thing is the private preview of Write API. So now you can directly push data into Pinot. Previously, you could only pull data from other sources like Kafka and S3. So now you can simply do a HTTP call to push data in real time to Pinot. All right. So with that, let me show you. So in the demo section, we'll actually go through this flow, right? We'll sign up with a new user who gets assigned to a workspace, and then I'll go through some of the features that I described before. So for the demo, this is for the demo only. I'm using a dummy account from this. So let me go ahead and sign up. So I go to StarTree.cloud. A pretty simple sign-up form. All right. So now I should expect an invite email from StarTree, and you can basically just confirm your email and get your hands onto the StarTree workspace. All right. So now, as you saw, there was some seconds difference between you registering a new account and a workspace being assigned to you. So this workspace is now dedicated to this particular user. Other users are not obviously going to see anything. They're completely isolated from others. And I recommend trying this out on your own, of course, but let me go through a sample workflow right now. So let me first, now that we have a new workspace, let me start with ingesting some data into this. And the UI will guide you through some of the things that are new to Data Manager. So let me start very simple. In Data Manager, you can either ingest data from external sources like Kafka. For this particular demo, I'll just use a demo data set that we ship along with the product. So let's say I want to take the complex website and then create it. And then I can go and query it in the new query console, like so. Right, so pretty straightforward. This was a small file, so the ingestion was pretty instant. The other thing I could do with the new trial is I can also invite some team members. So in this case, I'm going to invite my colleague Neha here from her email. So let's say we have another email like so. And this is pretty powerful, right? So especially for new development, this makes the whole experience very collaborative. So you can create data sets, and then any of your team members can just join the same workspace and get started. So while she'll go through the same flow as I did, except the sign up with her new email, accept the invite. While that's happening, let me also show you another ingestion flow here. So go back to, in this case now, let's pick Kafka as the source. So when you sign up to a new workspace, we automatically create a demo Kafka connection with some sample data in there. So you're ready to go. You can start ingesting from Kafka without bringing your own data. So in this case, we are actually pulling events from GitHub and pushing it into Kafka at some sampling rate. So you can actually analyze GitHub events in Pinot in real time. And as you can see, it's already populating auto-populating the topics that exist in our Kafka cluster that's running behind. All right. So the first thing it will do is just sampling data is important. So it can tell you from your data source, just sample a few records, and then we can do our data modeling based on this sample data. So this is the second step, which is the data modeling. You can, Pinot, the StarTree has automatically inferred Pinot schema based on the schema it detected from your original Kafka topic. And you can extend this. So these are the columns that existed already in Kafka. We can also add new columns and so on. And as I mentioned, we automatically also infer the time column. In this case, I'm using merge time milliseconds, and then start creating the actual table. You can do things like add indexes or change encoding of a particular column, and so on and so forth, including things like replication factor, retention, and so on. So for now, I'll just skip over all of that, do a final preview of this data. And this is all live, right? This is actually connecting to Kafka and then creating the data set in Pinot. All right, so now the table is set up. I can go back to my query console and now query the GitHub events. And these are live events that we are seeing from GitHub. So at this point, I'll switch over to the invited user. So let me go log out from my workspace. OK, and over to you. So now she's going to sign in as the invited user, and then she can continue the workflow. Oh, it's already copied. You can just paste it.
New laptop, new shortcut.
Right.
Cool. So you can see that Chinmay invited me. We can look here. The below one was Chinmay, and now I'm in this workspace as well. We can go to Data Manager, and I'm seeing the same workspace view. So I'm going to move on to just talking about what we're doing under the hood, how everything is working out, talk about the new concept that we've introduced, the workspace. So like Chinmay mentioned earlier, at the heart of all this is this new concept called the workspace, which is a unit of isolation that we've introduced to kind of give us this logical view over one shared physical cluster and to help us enhance multi-tenancy. And we've made this workspace a first-class citizen in StarTree Cloud. So what that means is across the stack, if you have your data plane with like data manager, query console, the Pinot cluster, and you are coming in as users to data manager or query console, you could see that there was like a workspace view. You're only able to log in and see your own data sets and create data sets in your own workspace. Similarly, when you're querying, you should be able to only see the data sets that you have created or your team members have created. So this is the same cluster where all signups are happening today, and we both only got like our own properly isolated workspace view. Similarly, like if you invite somebody, invite them to your own workspace. In the Pinot cluster, if you've created some tables, they now have the context of the workspace with them. So this is how, like top to bottom, we are ensuring that a clean, logical, isolated view is being served to you. And now we are using this workspace concept to encapsulate common attributes, like setting up RBAC policies on workspace level now, or setting up quotas which are also on workspace level. And this workspace is logical isolation. It's not necessarily physical isolation, but it can be. So we'll just talk a little bit more about that later on how we have the concept of tenants, and now we have the concept of workspace, and how there's full flexibility in mixing and matching that and achieving different kinds of isolation. And the great part about this whole architecture is that now this new concept is applicable for not just serverless, but also for our other offerings. So dedicated SaaS, BYOC. So you could have BYOC use cases where you want to create teams that need separate workspaces. So that capability is available as well. And then, so how is all of this orchestrated in the back? That's happening via RBAC. So just like a quick refresher on what RBAC typical concepts are and how we've applied them on our end. So we have a subject, which is usually like users, user groups, or service accounts. And then these subjects assume roles, and these roles are used to kind of control what the subjects can do or cannot do with the help of defining policies, where you'll say, hey, this is my resource, these are the actions that are allowed or disallowed. So applying this to our entities now, our subjects are either registered users or service tokens, and roles that they can assume are like workspace admin, workspace reader. And then the policies that we define are now on the workspace with actions like, hey, read the table, query the table, and if you're the workspace admin, then delete, update the table, and so on. So when you sign up or when you create a programmatic access token, all this mapping is being created behind the scenes for you. So when you log in to the apps and interact with the entities like data sets in Data Manager or connections in Data Manager or alerts in Third Eye, all of these entities and apps now are context aware. They know what workspace they are in, and they're inheriting all the RBAC policies that are set on the workspace. Now let's talk a little bit about the Pinot cluster part of this. So how are we achieving the same logical isolation in the Pinot cluster? So we've introduced, like we took this opportunity to introduce the concept of database in Pinot. So database must be a familiar concept to all of you. You must have seen it in like MySQL, Postgres. It's like a way to logically group tables together. So same concept here. It's a logical isolation concept to group certain tables together. And with this, now our table names have a logical part, which is the actual table name you will use, and then a fully qualified name or the physical name of how it's stored. And this is completely transparent to the end user, so you'll continue to query your table or use your apps with just the logical name. And once we get, like Pinot is transparently behind the scenes, just converting that logical name to the fully qualified name. And the apps that you're interacting with, they are helping us set the database context or the workspace context in the headers for all the requests that they are making to Pinot. So this is how we're able to do things like, hey, multiple tables might sign up today and just create a table called test or foo. But as long as they're all in their separate workspaces, we are able to isolate them and also distinguish and handle it all properly. And then finally, it was just about tying this database concept one-on-one with workspaces, and also being able to apply the same RBAC policies that we are creating at a workspace level to the database concept in Pinot. And this database concept is, or the workspace concept is, like I said earlier, flexible. It's not mapped to the physical concept of tenants. And why we did that is because now with this, let's say we could have had one large tenant and then multiple databases created within that same tenant. Or you can have multiple tenants and map your workspaces, like one per each tenant, and achieve like true logical as well as physical isolation in one shot. Or in some cases, you might even want to spread your databases or workspaces across tenants if you wanted to isolate tables within a workspace as well, or have some table spread across multiple tenants, like in advanced cases of like tiered storage or separation of consuming and completed segments and so on. And now how are we handling and how are we thinking about the scalability of our workspaces? Like you can see today we announced this and we're getting a lot of signups. So what all is in our toolkit to make sure that we are able to scale with all the data that's going to come in and the signups that are happening? So one part is the compute scalability. So we have automation that's constantly monitoring the underlying cluster capacity, and based on that, new capacity can be added, and then we'll be able to transparently rebalance and shuffle and balance all that data around. To make sure that the isolation works well at scale, we have now set up quotas, and those include like QPS quotas or ingestion throttling quotas and even storage quotas. We also have enabled features like automated expensive query killing, which is constantly instrumenting the resources, the memory CPU used by every query, and then anytime it gets near to causing an kill, it will automatically kill the expensive query. Also some safeguards like looking at large abusive broker response payloads and then just killing those queries as well. And for data scalability, we have our cloud native storage or tiered storage. And we'll talk about this in the next few slides a little bit more. So with tiered storage or cloud native storage, we're able to keep data on local disks SSDs, also on object store. You can have both, you can have just one, and then there are flexible policies that allow you to migrate data from, let's say, local tenant, set up some migration policy such that, hey, after this retention or this much storage, move it to the other tenant, offload the segments to remote store, and then just query the same table seamlessly without having to know where your data is placed. And we've also made a lot of optimizations and added several techniques to be able to continue having the data and the latency still be sub-second. Some of them include ability to just pin the indexes and the metadata part of our segments locally while keeping all the like the forward indexes and the dictionaries on the remote store. Or just like really thinking of, hey, what is the data that we need to fetch? So we strictly don't do lazy loading. Like many systems who claim tiered storage are actually just fetching like entire segments, caching them locally, and then just treating the local disk as a cache. But what we are thinking, the way we thought about this was just making sure we only fetch what we really need. So in like an example like this, where we know that, hey, we just need impressions or region column, so we'll only fetch the relevant buffers for those columns. And then even going beyond that, that to read an inverted index based on the offsets, we know exactly what bytes we need to read. Now, once we know the documents that we need to read in the post-filtering phase from the impressions column, we just go and read those chunks all in parallel, and we pipeline the fetching and the execution. So lots of things in our toolkit here to make sure that we're able to handle all this data at scale by putting it on cloud native storage and then still keep it fast. And with that, I will call Chinmay to wrap it up and tell us what's coming up in this.
Yeah, thank you so much, Neha. Yeah, so just to summarize what you've seen here today, right, this is really a win-win for new developers. They have zero friction to get started and start building. For us, it's a much better architecture, as you saw, right? It allows us to essentially have one cluster instead of hundreds and thousands of clusters, and we can scale it organically, have the data automatically go to cheaper cloud storage when needed, and at the same time provide the right isolation so that each workspace feels like it's its own virtual cluster. So it's a great start for trials. What's coming up is we want to now release the same abstraction for our other production tiers, which is the BYOC and dedicated SaaS. And this is a common use case. Many of the, especially large organizations, even medium to large organizations, have the need to provide the same isolation guarantees between their teams. So you might have workspaces for data and finance completely separate. They should not be able to access each other. Both logical and physical isolation, right? So the workspace concept is applicable even for the existing production customers. So we'll be rolling that out very soon in the next few months or so. The other thing is currently we are only doing free trials on serverless. Right? So right now you don't need a credit card to get started, but in the future you will be able to pay as you go. So pay only for the resources that you're using. So this is basically gives you an entry-level option. You don't have to commit to either BYOC or SaaS for your first production use case. And then we'll have an upfront calculator for estimating how much cost that will be. So that's coming up soon. And finally, of course, things like usage dashboard, metering, this will be available in our central. So we'll be rolling out a cloud portal where you can go and manage your workspaces and see the usage of your workspaces in real time. That was it for us. Thank you for attending. And as you know, Kishore mentioned this already. For today and tomorrow, we're running a special promo. If you sign up in these 2 days, you actually get a more storage, basically 0.5 terabyte of storage for the special promo signups. But other than that, please try it out yourself and give us your feedback. And thanks again for attending the talk. Thank you.
They next door, it should be home. Walk to the gate, see a dog without a leash.
We can take questions.
Allegedly, this is where my daughter be. Knock on the door, I guess I'm about to see. Fall on the door because my knees are weak.
We can take questions if you have any. Do we have a mic for them or?
So I've got two simple ones. So you used the database and workspace like interchangeably, almost synonymously. Are they one and the same?
So workspace is a concept we introduced in StarTree across the stack. When we thought about what we should do for Apache Pinot, we wanted to keep the open source story clean, something that made sense for Apache Pinot as a database. So there we introduced the database concept.
Oh, okay.
And then for us internally, we just map it one-to-one, yes.
Got it, okay. The other question was probably for you. With the RBAC slide that you had, you said there are like two different types of like users. One is an admin, the other one is a reader. But when you invited her to be part of the workspace, I don't think you had like an option to like specify what kind of user she is, right?
Correct. Yeah, so for now we are defaulting to invited users are all admins of the workspace.
Okay.
In the future, we already have that capability. It's just not in the UI today. But in the backend, we can actually set policies that restrict to what extent you can. So you may be able to query a table, may not be able to create new tables. So there's a very flexible set of policies that we do use today, and we will soon roll it out in the UI as well.
That's good. Thanks. Good demo. Thanks.
So I had a question about the serverless setup you showed. So do you have any guidance on what that kind of architecture would be good, what kind of use cases that would be good for, and in what kind of use cases wouldn't work or?
Yeah, so again, this is meant for the free trials on StarTree Cloud, right? So anyone who's new to Pinot, we believe this will easily benefit them to get started quickly without thinking too much about the infrastructure. So it's a great sort of starting point for both Apache Pinot users as well as for StarTree Cloud users. But the good thing is we have and by the way, you get the full experience. There's no limitations on what you get from a trial workspace. You get all the data manager, third eye, whatever you see for production users, you get all of that here. The only thing we restrict is sort of storage and the QPS. Right? So that's a great way to also learn about and try out the product for yourself. And the other thing I would add is once you have tried it out, we can easily move you to a more sort of production-ready, like a completely isolated tenant if you have, as Neha mentioned, we have the ability to not just logically isolate, but physically isolate as well for production use cases. So that's always an option. If you want to either increase in terms of like storage or like overall availability and capacity, that's an option.
I have a question on the cloud native disk. I'm wondering if that's an extension on top of the tier storage, and also if the cloud native disk is only for the serverless tier, or is it in general?
Yes, so cloud native storage is essentially tiered storage. If you're asking about extension, it does use all the plugins that are available or the interfaces that are available in open source. But in open source, you can only do tiering of actual local storage like HDDs, SSDs. But the plugin we have allows you to also put it on remote storage like GCS, S3. And it is not just for serverless. It's in the product. So it's across BYOC dedicated. Yeah.
Thank you.
You mentioned some databases spreading across multiple tenants, right? What and why would you want to do that generally?
So you mean 3 tenants and split
Single
this
database,
way?
yeah.
So typically, like if you also see the cloud native storage picture, the way, this is fine.
Okay.
So the way we, like a typical tiered storage table, the way we set it up is, hey, for let's say 7 days, you want to keep stuff locally and then move like beyond 7 days, everything to like the object store. So the way we like to configure this is have a tenant, which is a local tenant or serves all the data that is local. And then you can keep like really beefy compute nodes there because that's going to be like your most queried set of data. And then beyond that, you can just, you don't need like the actual storage. Those can be like lighter weight machines. And it can just be one pool that's shared by like multiple tables. Because like the whole premise there is that it will be queried less frequently, so a good chance to amortize the cost across multiple tables. So that is one use case where the same table splits across 2 tenants based on some policy like age or size. That's the use case for that mainly.
Okay, thank you.
So I know that it's very early stage, but my question is for existing Pinot users, say consider they have a lot of data, big size, petabyte scale maybe. So how do they transition to serverless solution?
Right. So It might, so it depends on, what, again, this is, if it's a small amount of data, then yeah, serverless might be an option. For petabyte scale data, I wouldn't recommend serverless. Then that's more on either the BYOC or SaaS offering. And again, it's not very hard to get started on the other offerings as well, especially if you're already using Pinot at a certain scale. We have tools to migrate data from an open source Apache Pinot into StarTree Cloud. Whether it's serverless or BYOC, that's sort of orthogonal. So there's tools to sort of get started with StarTree Cloud. But in that high scale scenario, I would not recommend serverless. It would probably be like a SaaS thing to get started. That might be the easier one.
So there are customers who are having big database, right, for Pinot. So
Can you repeat that, sir?
large database of Pinot.
Yes.
There are customers.
Correct. Yeah. So we often see typical like average in the terabyte range is pretty common. Often take tens of terabytes is the common one. If you've heard the Stripe talk before, like one of the tables was about 1.5 petabytes in Pinot. So Pinot definitely, and Pinot and StarTree Cloud both can support very large scale data sets. That's correct.
I have one more questions about separation of duties. Like in case, it could be bring your cloud or completely managed service. So in that case, managed service, it is more responsibility of Star team, kind of providing the availability, reliability, and other stuff. So you would be having those set of solutions, kind of, and how that impact the cost.
Sorry, maybe I can ask for clarification. So you're asking in BYOC versus SaaS, which one is fully managed and cost implications thereof?
Yeah.
So both are, in terms of support and SLA, both are the same. You get the same experience in using BYOC and SaaS. The only difference is which cloud account is the solution deployed in. But for both the solutions, StarTree actually takes care of like the 24/7 on-call support issues, and that's consistent in both the cases. So no difference there. Okay, thanks. I think we are almost out of. Is there a last question maybe? We just.
Is the management and control plane experience when, let's say, someone moves from serverless to dedicated or BYOC remains the same?
Yes. Yeah. Great question. So the tools that you saw today, Data Manager, Query Console, they work exactly the same in the dedicated account. We will be, as I mentioned before, we will be providing a cloud portal for customers for better management of their workspaces. So today it's very basic in the trial experience. You can just create. We can't really do capacity planning through the UI. So that's something we will plan to roll out in the coming in this year. Okay, I think that was the last question. Cool. Thank you so much for attending, and hope you try it out for yourself. Thank you.